Number 16, 27 to the negative 2/3. The negative tells me that I am 1 over 27 to the 2/3. The 2 tells me to square whatever I have. And this 3, the denominator, tells me what root I should have. And that is all talking about the 27. So I can take the cube root or square the 27 first, it doesn't matter. But this will be 1 over the cube root of 27 is 3. I still have to square it, so the answer is 1/9. Number 17, you have 8 to the 1/2 over 8 to the 1/3. Two ways to do this, but the first way, you can say this is the square root of 8 over the cube root of 8. I know that the cube root of 8 is 2, and the square root of 8 is 2 radical 2, because 8 is 2 times 2 times 2. Square roots, I can take the 2's, pull it out, so you have 2 radical 2. Those 2's will cancel, and you get the square root of 2. The other thing you can do is you can subtract exponents, which is what dividing is subtracting exponents. So that's really 8 to the 3/6. I need a common denominator. That's why I'm changing it to 6 minus 2/6. That's 8 to the 1/6, or the 6th root of 8. Those two are the same answers, even though they don't really look the same. Number 18, you have x to the 2/3 to the 6/5. When you have exponents to exponents, you multiply. So the 6 and the 3 cancel down to 2. Nothing else cancels. That's x to the 2 times 2, or 4/5, or 5th root of x to the 4th. Number 19, you have x to the 1/4 times x to the 2/5. In this case, you add the fractions together. Common denominator is 20, so that's 5/20 times x to the 8/20. You add, so that's x to the 13 over 20. Number 20. 4th root of 144 x to the 8th. 4th root means I need to take groups of 4 out. I can see I have 8 x's here, meaning I'm going to be able to take 2 x's out and nothing else will be left inside. The 144, it factors to 12 and 12. 12 factors to 4 and 3, 4 and 3. And the 4's each factor to 2, 2, 2, and 2. So 144 is really 2 times 2 times 2 times 2 times 3 times 3. I'm taking out groups of 4, so I will take all 4 of these 2's out. I don't have 4 3's, so I leave them in. So it's 2x squared times the 4th root of 3 times 3 is 9. Number 21, you have 3/3 root of negative 64. Answer is negative 4. Because the cube root of anything is, of course, what times what equals 64, which is 4. You can take cube roots of negatives, you can take 5th roots of negatives, but you cannot take square roots, 4th roots, even roots. So that's where you get this negative from, is negative 4 times negative 4 times negative 4 is negative 64. Number 22, 1 over the cube root of a. To rationalize, you actually need 2 a's, because you're trying to match the number inside with the number outside. This is the only way you're going to get a cubed inside, and the cube root of a cubed is just a, and you have the cube root of a squared in your numerator. Number 23, 1 over the 5th root of the square root of 11 squared. You're rewriting that in rational exponents. Remember, 1 over this means that you have a negative exponent. The 5 is the denominator, the 2 is the numerator, and it's all 11 to that power. 24, 4th root of x minus 5 equals 2. To solve, you take each side to the 4th power, so this is x minus 5, 2 to the 4th is 16, x equals 21. Number 25, f of x equals negative 1/3 square root x minus 2 plus 7. This negative is a reflection, again, across the x, same as the one that we did earlier. The 1/3 is a vertical compression by 1/3. The 2 is a shift 2 to the right, and that 7 is positive 7 up. Number 26, f of x equals the square root of x plus 4 minus 5. You know the domain, you can't have negative numbers in here. You can have 0. So the first place we'll start is what makes this 0, which is a negative 4. The next place, because you're taking square roots, you want to try as many what are going to get you whole numbers as possible. So for instance, the square root of 1 is something that I know, so I would put a -3 in. So -3 plus 4 is 1, the square root of 1 is 1, minus 5 is -5. I'm sorry, -4. And this is a -5 because 0 minus 5 is -5. The next number is 4, that I know has a perfect square root, so if I put a 0 in there, that's the square root of 4 is 2, minus 5 is -3. The next number I know is 9, so 5 plus 4 is 9, square root of 9 is 3, minus 2 is -2. So -1, 2, 3, 4, -1, 2, 3, 4, 5, you have a number there, -3, -4, 0, -3, 5, -2. Not the best drawing, but that's more or less what it looks like. The domain of this, because you cannot go any further than -4 on this side, your domain, which is all of your x values, is x such that x is greater than or equal to -4. It goes this way. Your range is not going to go any lower than this because you can't go to the left, so your range is going to be y such that, or f of x I should say, such that f of x is greater than or equal to -5. For piecewise functions, you're looking at 3 different intervals here. So you know you have an interval that is less than -3, so things like -4, -5. You have things that are between -3 and 1, like -2, -1, 0, and 1. And you have things that are greater than or equal to 1, like 1, 2, and 3. So first, if I put in a -5, which is less than -3, and my answer is -3. Same thing for -4. It's less than -3, so my answer is -3. Same thing for -3. I know that it's not equal to here, but you do want to see where what behavior it is at this end point. So everything is -3 at -5, 4, and an open circle on 3 because not equal to. Then you go to -3. It also falls in this category. If I put a -3 in there, I end up with -3 minus 2, or a -5. I put a -2 in there, falls in here, so that's a -4. This is a -3. I put a 0 in, that's -2. I get a -1. Same thing. I know it's not equal to 1, but I need to know what happens at that boundary. So -3, -5, close circle, 4, 3, 2, open circle on 1. So I see that that happens. And if I plug in a 1, it also falls in this category. I get a -1 there as well. If I put it in 2, I get a -2, and then I get a -3. So that really fills in my circle here, here, and here, and I see that I get a line. 28, I'm trying to write a piecewise function. I see that I have 3 intervals again. So that's written f of x equals, and I'm going to have 3 different places that I'm writing things. Here it looks like I'm less than 3, open circle. So x is less than -3. Here it looks like I'm between -3 and 3. So -3 is less than or equal to, because closed circle. X less than +3. And here it looks like I'm greater than or equal to +3. This line, it's always at -5. So that's why I write a -5 there. This line looks like I cross at 1. That's my y-intercept. I have a slope of 2/3. So I'll have 2/3 x plus 1 in slope-intercept form. And here it looks like my answer is always equal to 5. Number 29, you're evaluating a piecewise function for certain things. For part A, if x equals 1, then you look over here. Which interval does it fall in? X equals 1 here. And the answer is always 7. So that is 7. F of x equals 7 here. For B, where x is -7, that one is less than -5, so we would plug -7 into the 2. So 2 times -7 plus 4, -14 plus 4 is -10. For the 3, which is greater than 2, I have x squared plus 1, or 3 squared is 9 plus 1, and that answer is 10. For number 30, you have 2 functions, and you're looking for different ways to combine them. If I add the 2 functions together, that's simply f of x plus g of x. So x squared plus x minus 6 plus x minus 2. X squared, x plus x is 2x, -6 plus negative 2 is negative 8. For g minus f of x, you're going to take your g of x, or your x minus 2, minus x squared plus x minus 6, subtracting negative x squared. X minus x is 0. Negative 2 minus negative 6 is a positive 4. F over g of x, you'll put f over g, like it says. You can see that this will factor to x plus 3, x minus 2 over x minus 2. X minus 2's cancel to be x plus 3, and the domain is all real numbers. X cannot equal 2 because that would make the bottom 0. For part D, this means to plug 1 into G and then plug your answer into F. So to plug 1 into G, that would be plugging 1 into x minus 2. 1 minus 2 is negative 1. So then what's f of negative 1? Plug negative 1 in for every x that you see, so that's negative 1 squared minus 1 minus 6, or 1 minus 1 is 0, negative 6. For g of f of, meant to say g of f of 3, if I plug a 3 in for f, that's 9 plus 3 is 12, minus 6 is 6, and then I plug a 6 in here, 6 minus 2 is 4. Number 31, f of x equals 1 half x plus 1, and you're trying to find the inverse function, or f negative 1 of x. Inverse means take your x and your y and switch places. So I'm going to change this. That's really the same thing as saying y. I'm going to switch their places, and then I'm going to solve for y. To do that, use order of operations. Subtract the 1. Multiply both sides by 2 to clear the fraction. 2x minus 2 equals y. So the inverse of f of x is 2x minus 2. Number 32, you're looking at combinations. So if you have 3 shirts, 6 pairs of pants, and 4 ties, that means you multiply them all together, and you get 72. Number 33, you have 3 spaces for your license plates. This is a letter, a letter, a letter, a number, a number, a number. Letters, well, there's 26 of them. I didn't say you can't repeat, so you would have 26 there, 26 possibilities there, 10 numbers there from 0 to 9, 10 there, and 10 there, and 10 there. So you multiply again all of those combinations, you end up with 17,576,000. Number 34, 13 people in student council, then you take the total number of people that you have, factorial, over that number minus the number of spaces that you have. And because there is order matters here, then that's the only thing you need. So this is really 13 times 12 times 11 times 10 times 9, dot, 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 dot. This is 10 factorial, or 10 times 9 times 8 times 7, dot, 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 dot. All of this is going to cancel because you see them on the top and the bottom. So you really end up with 13 times 12 times 11, or 1,716. Number 35. The total number of rolls that you can have, there are 6 possibilities for the first die, and there are 6 possibilities for the second die, so you just multiply those probabilities together, possibilities, and you get 36. That's going to be your denominator. That's a total number of rolls that you possibly have. Then you see which ones have a sum of 9. You have 3 and 6, you can have 6 and 3, you can have 4 and 5, you can have 5 and 4. Those are all of the rolls that can add up to 9, which is 1, 2, 3, 4, 4 over 36, or 1/9. Number 36, if you are picking out marbles without replacement, there are 18 total marbles. 5 of them are the ones that you want first. So there's a 5 out of 18 chance that you pick the correct one. Next, if you don't replace it, now all of a sudden you're at a 17. There's still 6 blue marbles left, so multiplying 6 and 18 cancel. This is really 5 over 51. Number 37, if there is replacement, you would have 7 over 18 probability of getting the first one correct, and then 5 over still 18 because you replace that other marble of getting the second one correct. You end up with 35 over 324 possibilities of that happening.